So for those of you that don't know, I work with the Penn State Ice and Climate Exploration Group, so my work is in modeling ice sheets. So it's very difficult for me to figure out a project that would be relevant to the work I'm doing. So I'm gonna briefly walk you through sort of my train of thought and why I ended up attempting to build a precision altimeter. So there's a huge data gap present in pretty much all of Earth science. But in ice sheet modeling specifically, you have such large scale areas and you really don't have enough data covering those areas. And I work in the Amundsen Sea embayment area, and as you can see, this is the scale of 500 kilometers, and it's a huge area. So it's hard to get data over that much area to begin with. Not only that, but it is not very accessible as it is in Antarctica. So ice sheet motion is basically constrained by so many different physical processes and characteristics of the ice and the bedrock beneath that having more data is beneficial, and it's the only way that your model really becomes meaningful. So there have been a lot of but successes too, at conducting remote surveys, airborne surveys. This is some example of the ice bridge data. Unfortunately, can't see very well, but the main takeaway of this slide is that despite all these flight lines, there are still white areas. And that's a big problem because then the model doesn't have data to inform it, and ice motion, as said, very complex, and you basically want to have really good data coverage and really, really high resolution data. And speaking of high resolution, this is bedrock data. Obviously, bedrock is not that smooth. There's no way. Like I said, there's hundreds of kilometers, and it's really the small scale undulations in the bedrock that will affect ice motion a lot. So high res data is a problem, and data coverage is a problem. So there have been attempts at airborne surveys. This is Buckham et al. In 2011 did a UAV-based survey of King George Island in Antarctica, one of the smallest island on the peninsula, but it is still 1,250 kilometers squared, so it's pretty big. They did a GPR survey, which just in general is EM energy coming down from antenna, scattering, and being transmitted and reflected through interfaces in the ice. And to do that, they used this monster. So that's a huge helicopter. And while that's not really feasible for me to do per se, I thought, okay, well, why not downscale that to a drone? I figured that's possible, and while that project was absolutely out of the scope of this class, I figured, okay, first step is the altimeter, because that is the surface of the glacier. You need to know how high above the glacier you are, because you have to basically use the ice-air interface to back out any reflections you see. And so it's not always straightforward flat, it's often very heavily crevassed. This is the Wolverine Glacier in Alaska, but still. So design aspects, I incorporated what I wanted it to be precise, I wanted it to be lightweight and compact, and I wanted to have a continuous data collection, because if you're flying around, you're changing altitude very rapidly, you need to have continuous data collection at a high enough sampling rate to keep up with your GPR survey or whatever survey you're conducting with the drone. I wanted it to be operational in extreme environments, and because it gets real cold in Antarctica, the interior of Antarctica, I think, gets down to -50 degrees C. So couldn't use this guy there, but either way, this guy goes down to -40 degrees C, up to 85 degrees C, so it's not too bad. Pressure operating range is well within what you'd expect in an environment where you're trying to actually conduct an airborne survey of ice and glaciers. And the resolution for it, the minimum obtained resolution for this specific breakout was, I think, 6 centimeters in altitude, so whatever that is in pressure. But I got it maybe down to 30, that's the typical one, but it is possible to get it down to plus or minus 6 centimeters, so that's really good. Don't know how they did that, because mine drifts quite a bit, by more than 30 centimeters just sitting here. But this is my prototype. As said, I didn't realize that there was that really cool toolbox, otherwise I wouldn't have sketched this out painstakingly. But basically, there's a mess of wires, but more or less it's just an LCD screen that is hooked up to the breadboard, which is also hooked up to my sensor, and then I have a button to change modes and a potentiometer to adjust the contrast on the LCD screen. And I basically programmed it as a state machine. I have an initialization state where it starts up the sensor, sets the baud rate. I have an altitude sensing mode in both feet and meters above sea level, and then I have a barometric pressure sensing mode. And I mean, they're all the same thing, but because, as John was saying earlier, it takes the pressure and it converts it to altitude. And here's the equation by which they do that. Apparently, the user can input a given value for sea level pressure to account for local weather conditions, but I cannot figure out how in the world I do that, despite going through the data sheet multiple times. But this is a video of me changing modes because I figured it'd be up there and you guys would be right here. It starts up, and then I press the button and it switches to feet. Press the button again, it switches to the barometric mode, and then I can switch back to altitude mode in meters. And improvements that I'd like to make, I'd like it to log data and transfer data remotely, like through Wi-Fi or Bluetooth, because if you have it on a drone and it's flying around, you don't want anything on there to like store. It's going to be a lot of data. You can't mount something on there to store the data very well because it's going to be heavy. It has to be lightweight. So I want it to be able to transmit data. I would also like it to be more compact and more rugged design. So I need like a chassis that's insulated. I use the breadboard to prototype, but I'd like to use the Arduino Pro Mini, which has the same number of input pins and weighs less than 2 grams, and it's about this big, so that'd be nice to have. And I'd like to solder the components, which was my biggest challenge. I attempted to, I ruined the first sensor, because I'm severely anemic, so I'm always tired and my hands are shaky, and so I drink coffee and my hands are shakier. And so I can't solder, especially because this was through-hole soldering. I gave up on that very quickly. So I'd like to do that in the future, or have someone do it for me if I were to make this a more solid prototype. For field use, as I said, I'd like to have an insulated chassis. I'd like it to be battery powered, which I just didn't get to. I have a battery. I like to have a standby mode so that if it's not being used, it doesn't turn off, but it will at least save power. And I need an on-off switch because right now it's literally just plug in and unplug. And it's drifting quite a bit. I mean, you're welcome to come up here and look at the values, but it's not moving, and well, it's not moving up or down, and yet it thinks it's moving by several centimeters. And I also have the problem of the altitude being off, but I'm sure that's due to the user input thing that I cannot figure out how to do. So I feel like if I really went into the coding a little bit more, and it does know when I go up.
Okay, so.
But then it also knows when I go down, so that's good. And I walked up and down the stairs, and it seemed to really be affected a lot by the fact that it was cold in the stairwell because of the pressure. So so my biggest challenge was soldering, or not really being able to solder, and the fact that my computer has been iffy. I can't really plug in the breadboard very easily, so every time I had to upload the code, it was a headache. I had to restart the computer, plug it into one thing, select the port, plug it into the other thing. So either way, that was one of my biggest challenges, which wasn't even a design challenge. But I'd like to do a demo for you guys. I have a link to a barometric pressure map currently of Pennsylvania, and I can show you that. And also, these are links to topographic maps, but take it for basically the elevation here is 1158 ground level, and I figured we're three floors up, right? Yeah, second floor. 10 feet apiece, so should be like, I don't know, around 1,200 feet. And I see 1129 on mine. So not quite right, but not bad.
Okay.
Not terrible. Not terrible. And let's see if the barometric pressure, this is going to be in millimeters of mercury, but oh no, that's not. So what I'm seeing on here is 97 kilopascals. So let's look at the Pennsylvania, if this ever loads or allows me to scroll. This worked really nicely. I have an app on my phone I can do this with in case that didn't work. So here's an altimeter. This is just GPS. This is 359 meters according to this phone. We're at 325 on my actual sensor. And in terms of the barometer, it's 970 hectopascals. So we're pretty on point in terms of what it's sensing. But the altitude, I just chalk that up to my not being able to calibrate it properly.
Okay, great. questions?
So did you look at doing like any kind of averaging of the sensor? Could you get the noise beat down?
I think if you average it out and didn't continuously collect data, it'd be fine, but considering that I want to have it on something that's flying, I kind of have to have it continually monitor that. So with that design consideration in mind, I did not do that because I feel like it wouldn't be very useful. But if I just wanted to use it as an altimeter, absolutely, would just have it average out every 10 to 50 samples, something like that. I think that would be effective. But again, serial plotter and serial monitor did not really work for me because I could not hook it up to, so it's kind of difficult. So basically it would be me writing stuff down as it changes, or taking a video of it and then writing it down. So it would have been a big time sink.
Cool. Where's the actual sensor?
Oh, right here. Okay, yeah. It was on the board, but it didn't like that. And so I just bent stuff around it. Like I said, the soldering, the first sensor, I had to reorder it actually. I messed it up.
Is the principle of operation just pressure? What does it actually measure?
It measures pressure, yeah, and then it converts it to altitude. I had the equation
Sure, yeah. let's do
right
so.
there, yeah. It's a little small, but
So
it uses it, yeah.
Yes.
Altitude based on measured pressure, user input of equivalent sea level pressure to compensate for local weather conditions and U.S. standard atmosphere to give altitude readings. So since it is U.S. standard, if I wanted to implement it elsewhere, I'd have to recalibrate it. But
yeah.
yeah.
Cool.
Which sensor was it? Was it the MPL? or-
MPL 3115A2.
Okay.
Let's see. Yeah.
Anything else? All right. Well, awesome.
Yeah, thanks.
Cool.
You guys want to mess with it, lift it up and down? Go ahead.
Did you try any of that kind of thing? Did you?
Oh, yeah,
did
yeah.
You measure the height of our building with it?
Yeah, I did. Well, since I couldn't get absolute height, but I got like stairwell height, and it's off every time. It changes. I'm not sure. I think really didn't like the fact that it's so cold in the stairwell, but it is quite a bit colder in the stairwell.
Up and down the elevator? Because it would be like more constant temp there, right? So you'd just go sit in there, let people come and go.
Where were you 2 weeks ago? No, that's a good idea. I could try that. Definitely try that.
Hey, you should go down the hallway and figure out what the head of the building is.
Yeah, yeah.
So we all can be more efficient.
Yeah.
Just sit in the elevator. Oh, don't worry. Don't
Did you
not
try to
doing
get
anything.
log data from it? You couldn't.
It doesn't. I can sometimes because it. Oftentimes it basically just doesn't recognize that it's in the port. Like there is no, like I cannot select the port because it doesn't say it's in there, but when it does recognize that it's in there, it continually restarts. Like the blue light flashes every single time. That's the only time I can actually upload the code though. So
The ultrasonic sensor.